Alrighty, so today we're going to be getting into some acid-base balance and the physiology of the body to try to maintain that. So just some first general things to keep in mind throughout the video. So an acid, I'm writing this big enough so that even if you failed your eye test you can read it, hopefully, has a pH lower than 7. Base has a pH of greater than 7, and that's on a 7 to 14 scale. Now, acids primarily dissociate into hydrogen ions acids will primarily dissociate into hydrogen ions, while strong bases dissociate into OH ions, hydroxide ions. Just ignore that. I don't really know where I was going with that right there. Alrighty. So, if there's a high presence of hydrogen ions or a high concentration of hydrogen ions, I'll be using brackets to indicate concentration. That means that the pH will be low. So high, low pH. If you have a low hydrogen ion concentration, you'll have a high pH. And then if you have, there's a trash bag here. High concentration of OH minus will equal high pH. And a low OH minus concentration equals low pH. There you go. That's just the basic chemistry behind it all. I don't feel like going into all the calculations that go into calculating pH and the concentrations of it. So that's all you really need to know for right now. Alrighty. So there are a couple different mechanisms we can use to maintain pH. So first of all, we have chemical buffer systems. And then we have respiratory mechanisms. And 3 renal mechanisms. And then here, I'm just going to move this over here for, that way we can refer back to it. So high H plus concentration, go to the low pH. Really, we'll be dealing mostly with hydrogen, so I might just only repeat that. Low hydrogen concentration equals high pH. Alrighty, I will just erase that part and be back in a minute to explain the first one, chemical buffer systems. Alrighty, plus one little detail I forgot to mention. Blood pH is equal to 7.35 to 7.45. So there's this narrow window that we want to keep pH in so that we don't die. And so to keep that, we use these 3 systems. So the first system, the chemical buffer system, has 3 main components to it that I want to teach you. So let me just grab my cheat sheet here. I ain't no doctor. I need cheat sheets. Alrighty. So buffer systems typically, when there's a high pH, they'll release H plus ions to bring pH down. If there's a low pH, something will bind to the H plus ions to bring pH up. Because really when we're referring to hydrogen ions here, we're talking about free hydrogen ions, unbinded hydrogen ions. So they'll release hydrogen ions from a compound so that there are more hydrogen ions floating around to bring pH down, or some other molecules will bind to the hydrogen ions in order to take them away from their free-floating state so that you bring pH up. Alrighty, so one of those buffer systems is the carbonic acid bicarbonate system. Alrighty. So this is just a pretty simple one that just goes exactly with that rule that I just said about binding and releasing. So essentially we have this reaction, H plus HCO3 minus equals H2CO3. So this is hydrogen ions, this is bicarbonate ions, and that is carbonic acid. So this reaction can go either way depending on what kind of pH situation we're dealing with. So if we have too much hydrogen ions, which is low pH, this reaction will be shifted this way because we have more of these that we want to get rid of. Because we have so much free hydrogen that we need to get rid of some of it and turn it into that so pH doesn't get too low. Now, if we have, grab this, kind of wish we had dry erase boards, but womp womp. Alrighty. Then when we have a low hydrogen concentration, or high pH, this reaction is going to go this way. The bicarbonate acid is going to break down into free hydrogen ions. Remember, free hydrogen ions is really what we're looking at here because those bring pH down, plus HCO3 minus. So that's if we have high pH and low hydrogen concentration because we want to get more of that hydrogen concentration. Alright, so that's the carbonic acid bicarbonate buffer system. The next buffer system I want to talk about is the phosphate buffer system. So this uses dihydrogen phosphate and monohydrogen phosphate. So in pH, well, let me just write this down at the top. Phosphate buffer system. And I'll use the little marker board when we talk about the protein buffer system. Alrighty, so this one uses dihydrogen phosphate minus and monohydrogen phosphate, which is HPO4 2 minus. Alrighty, so when pH is too high, so high pH, this is going to utilize the hydroxide. So high H minus, go to high pH. So when we have too high of a pH, in this case, we also have a high concentration of OH minus. So this reaction will take OH minus and bind it to dihydrogen phosphate, which is a weak acid, and turn it into water and monohydrogen phosphate, which is a weak base. So we take a strong base and turn it into a weak base. Bring pH down. Since we have too high of a pH, we want to bring it down. Now, when we have pH is too low, we're going to go back to using the hydrogens. When pH is too low, we bind hydrogens, which are strong acids, to the weak base monohydrogen phosphate and turn it into dihydrogen phosphate, which is a weak acid. So if you kind of see a scheme here, weak acid, weak base, weak base, weak acid. So we combine a hydroxide with a weak acid to form a weak base. So this is a strong base plus a weak acid equals a weak base. Strong acid plus a weak base equals a weak acid. So we're just bringing the power of the hydrogen and the hydroxide down a notch so that pH can be more maintained instead of being crazy polarized. Now, protein buffer systems. These are the most extensive buffer system in the body. So, typically, well, not typically, always, I'm pretty sure, proteins have amino acids will combine with at least one carboxyl group and then one amine group. So those two right there. They also have an R group and they also have a hydrogen down there. Now, when pH is too low, when pH is too high, so high pH, low hydrogen concentration, what we're going to do is we're going to take this hydrogen right there and make it go off and be free. So we're going to turn this into, I might as well just write it down here, R over C over NH2. I wrote this one a little too big. That's okay, girl. H, and then COO minus plus H plus. So we have that free hydrogen hanging around where we didn't before. So now we've made up for that low hydrogen concentration, and hopefully we can bring pH down a little bit. Now, when pH is low, so we have a high loose hydrogen concentration. There we go. R, C, H, NH2, COO, H. Alright, so this is our amino acid, and this time we have too low of a pH, or too high of a hydrogen ion concentration. So right now we have this. We have the amino acid, the protein, and hydrogen ions. So to get rid of these free hydrogen ions, what the body will do is it will, I'm gonna write it right here, it will take the hydrogen ions and bind it to the amine group. So you get NH3 plus and COOH. And that's how you get rid of that. That's a protein buffer system. Next up, we'll be going into respiratory mechanisms for maintaining bodily pH once I erase all this. Alrighty, so we just got done talking about chemical buffer systems. Now we're going to go on to respiratory systems. So, any condition that increases the rate of respiration, so hyperventilation, or decreases the rate of respiration, which is hypoventilation, will also end up affecting blood pH. So, as a general rule here, let me make sure you can read that. Not really, but it's okay. Hyperventilation causes alkalosis, which is high pH, and hypoventilation causes acidosis, which is low pH, meaning 4.5 greater than 7.45. Like that. There we go. So you'll notice that those are both still alkaline or basic pHs, but since we are talking about blood pH, anything lower than 7.35 is acidosis, and anything above 7.45 is alkalosis. Even though it could be 7.34 and still basic on the pH scale, we would call it acidosis because of the blood pH. Alrighty. So, low H plus and high H plus. Alrighty, so let me show you how this works. So, the bulk of it is going to fall into this reaction here. Alrighty, so we have CO2 plus H2O. It's a reversible reaction here. H2CO3, so we have carbonic acid going to H plus a bicarbonate ion. There we go. So that's the reaction we're going to be using. It's got a nice slant to it, you know. I'm really good at what I do here. Alrighty, so an increase in depth and rate of perception, so hyperventilation. If you think about that, you're going, you're getting rid of all your CO2. So we have a low CO2 amount, so low CO2, and that's going to want to shift the reaction this way. Because think about it, we have low CO2, we're going to want to replace that. So what do? We use this reaction and can take these two, take the hydrogen and bicarbonate ions, turn it into bicarbonate acid, and then turn that into H2O and CO2 so that we can maintain our CO2 levels. Alrighty. This then causes a decrease. When we drive the reaction this way, it causes a decrease in H plus concentration, and resultingly pH will go up. So that's what I mean when hyperventilation causes alkalosis, when a low hydrogen ion concentration. We're getting rid of the free hydrogen ions, turning them into CO2, so that low hydrogen ion concentration makes the pH go up, alkalosis. Now, conversely, I'm getting really tired of wiping down these boards. I have no upper arm strength. I played soccer and I wasn't a goalie. Alrighty. Hypoventilation. Where did my marker go? Found it. So we have hypoventilation, which is a decrease in the depth and rate of respiration. So we're holding on to more CO2. We aren't getting rid of it because we aren't respirating as fast. So we have more CO2 that we hold on to. Now, we don't want all this CO2 in the blood. We just don't want it. That's a waste product. We don't want that all in the blood. So what do? We drive the reaction this way, because when you have a higher concentration of something on this side, it's going to push the reaction that way, and conversely. Alrighty, so we're going to draw the reaction this way, causing an increase in hydrogen ion concentration. We're making more of these free hydrogen ions, and that will conversely lower pH. So as we see, hypoventilation, when we hold on to that CO2 and increase it in the body, we're going to convert that and make more free hydrogen ion and low pH. So hyperventilation causes acidosis, which is a low pH and high hydrogen ion concentration. Now, just as things that go on this side of the reaction can affect pH, anything that affects pH can affect how we respirate. So anything on this side can affect this side. So if we have a high pH, here, let me write this on red because it's going to be important for when we cover respiratory alkalosis, acidosis, metabolic acidosis, and alkalosis. So we're going to do that. Low pH. Anything that causes low pH or high hydrogen ion concentration results in hyperventilation. And then anything that causes high pH, this is the bad marker. Y'all can't read that. It's okay. Let me just switch real quick. Even though I already kind of messed it up. See, this is why all or nothing thinking is stupid. Therapy in the form of a awful YouTube video. Low H plus causes hypoventilation. Now let me show you why that's true. So, if we have a low pH, so high hydrogen ion concentration. So we start on this side, right? We have a high hydrogen ion concentration. This is going to shift the reaction this way. So we're turning more of the hydrogen and the bicarbonate ion into carbonic acid, into H2O and carbon dioxide. So we have more carbon dioxide then. Let me erase this. I messed up by putting it on this side. Low pH. Alrighty. So that's the stimulus. We have a high hydrogen ion and a low pH. That shifts the reaction to the left, which is your right. I probably should have mirrored this. Shifts the reaction to your right and causes an increase in CO2. Now, we want to get rid of all that CO2. So that's going to cause us to hyperventilate, increase the rate and depth of the reaction. So that causes hyperventilation. So, high hydrogen ion concentration causes, or low pH, causes an increase in CO2, and to get rid of it, your body will compensate through hyperventilation. That's the compensation. Now, if we have a low pH or a high hydrogen ion concentration, that's what I just went through, didn't I? Yep. We have a high pH, so a low hydrogen ion concentration. This means that we're going to end up wanting to shift the reaction to the right to increase that hydrogen ion concentration. So the stimulus is low hydrogen ion concentration. So when we do this, we get rid of more CO2. So we decrease our CO2, which is what is going to cause our body to want to withhold it, meaning hypoventilation. So we have low H+, we shift the reaction to your left, and that causes a low CO2, and to compensate for that low CO2, we're going to hypoventilate. So as you can see, pH, just as changes in respiratory rate can affect pH, pH can also affect respiratory, and that's going to be really important when we get into respiratory acidosis, alkalosis, and metabolic alkalosis and acidosis. Alrighty, before we get into those, I just want to quickly go over a very brief and kind of not crude in the sense of like PG-13, but crude, or I don't know, crude just in the sense of it's just like a gross overview of it. Alrighty, so the kidneys. When we have a low pH or a high hydrogen ion concentration, kidneys are going to, I did a weird thing with my D. Okay, that's okay. It looks like Kyohis. Okay, well, kidneys. Kidneys are going to secrete hydrogen ions and hold on to, reabsorb HCO3 minus bicarbonate ions. Now, that's going to lower the H plus concentration because we're getting rid of it, and that brings pH back up. Now, if we have high pH and a low H plus concentration, the kidneys secrete HCO3 minus and hold onto H plus. There is a reaction that goes into it, but my teacher didn't require me to know it, so I'm not going to require my fake fans to know it either. Alrighty. And I only really share this with my classmates, so yeah. So your teacher doesn't require it either. I don't know what's wrong with me. I just choked a Mountain Dew. Alrighty. So that is that. Now, I want to get into the clinical aspects of respiratory alkalosis, respiratory acidosis, metabolic alkalosis, and metabolic acidosis. So, that's going to bring us back to our respiratory mechanisms here. Alrighty. So, as a general rule, we're going to go over respiratory acidosis and respiratory alkalosis first. So, as a general rule, respiratory problems require renal compensation. Alrighty, just keep that in mind. Respiratory problems require renal compensation. So, first up, we have ourselves some respiratory acidosis. This means high CO2 in the blood and a low pH, below 7.35. Remember, that's not acidic on the pH scale, but it's acidic for our blood, so acidosis. Alright, so causes hypoventilation, because you see we have high CO2, that means we're not getting rid of it fast enough. So hypoventilation is the problem here. That can be due to like emphysema, pulmonary edema, injury to the brainstem and respiratory centers, all sorts of fun stuff like that. So now, we have high CO2. That's going to shift the reaction to your left, and that's going to make an increase in H plus ions, and the kidneys are going to help fix this by taking that increase of hydrogen ions and secreting them. Secrete H plus, reabsorb HCO3 minus. Now, if this is the compensation, it doesn't fix the problem. pH will be within normal limits if this compensation is complete, but the blood CO2 will still be high and will still be hypoventilated. Will we still be hypoventilated? Yes, we will. Sorry. I'm losing my mind a little bit today. Alrighty. Now, respiratory alkalosis. But as you see, respiratory problem required renal compensation. Got a big bunch of soggy paper towels. Now, we have respiratory alkalosis. I drew some on my hand and now it's spreading through the door. Alkalosis. Now, that is low CO2, and a high pH above 7.45. Alright, so what is this caused by? Hyperventilation. Because our body's going and getting rid of all that CO2, so we're going to have a low CO2. This can be caused by oxygen deficiency, pulmonary disease, stroke, anxiety, etc. Now, this is going to shift the reaction. Well, technically this one I feel like we don't shift the reaction so much, as the primary goal here is the kidneys want to get the pH back in order. So we aren't going to shift the reaction so much in this case, but rather we're just going to we're just going to secrete bicarbonate ions, CO3 minus, and decrease secretion of H plus. So it's not, there probably is, I'm just a student, okay, I'm just a student. There probably is some going back this way, but for the most part, the main goal is to get pH in order, because if this isn't in order, you'll die. And so it will secrete HCO3 minus and decrease secretion of H plus, meaning the H plus rises and pH goes down. But as with respiratory acidosis, even though your pH might be done, CO2 will still be down. And that means that you'll still be hyperventilating. Alrighty. Now, another rule of thumb. Now we're going to get into metabolic acidosis and alkalosis. Metabolic problems require respiratory compensation. Can you read that? Yes, you can. Okay, perfect. So, we have, metabolic acidosis. Metabolic acidosis. That is decreased, this is just how we measure it. Decreased HCO3 minus, so decreased bicarbonate ions. This is how we measure it in this case. It's anything below 22. I don't know how to say this, but that's just what my book says. Anything below that, and a pH below 7.35. Alrighty, so it causes excess acid production. And that can be caused by things like diabetic ketoacidosis, starvation, ketosis, or impaired ability of the kidneys to secrete H plus ions. So excessive acid production or loss of base, primarily caused by diarrhea. Diarrhea because in the GH tract you have a whole bunch of bicarbonate ions to help lower that pH, because it's coming right out of the stomach. You want to try and lower that so that it's not tearing up your insides because it's so acidic. So we have a ton of the GI tract. So if you have diarrhea, you're losing a lot of HCO3 minus with that. Alrighty, so as I said, metabolic problems require renal compensation. So we have low this and high this. So the reaction this way. So what is that going to cause? That's going to cause us to shift the reaction bloop, 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 that way. And that's going to cause an increase in CO2. So we have increase in CO2. And how do we want to get rid of that? We want to get rid of that by hyperventilating. So as you can see, if you see someone in the emergency room who's hyperventilating, they're either compensating for metabolic acidosis or that's the cause of their respiratory alkalosis. So they can be either having a high pH situation or a low pH situation. And that's why you can't just tell based on hypoventilation or hyperventilation. So if they hyperventilate, their pH will be back within normal bounds, but they'll be hyperventilating. And so, yeah. Now, metabolic alkalosis. I'm sure you kind of see the pattern by now. Alrighty. My notes. However, will I survive? Oh, that just opened up my binder. Give me a second. Alrighty. Binder's back in order. So, metabolic alkalosis. That is caused by an increased bicarbonate ion concentration, anything above 26 MEq per liter, and pH, a high pH, above 7.45. So, metabolic problems require a respiratory solution. Causes of this can be loss of acid, through vomiting, because you lose acid, your pH is going to go up, or too much base, such as taking too many antacids, too much antacid, still lay off the Tums. Now, as we said, metabolic processes require respiratory compensation. So respiratory compensation is hypoventilation. Hypoventilation. Because as you see, that means we have a low H+. We have a high pH, low H+. So that's going to want to shift the reaction that way. So we're going to want to hold on to our CO2. So hold on to CO2 so we have more of it to convert to hydrogen ions. So that means that we're going to want to hold on to it and hypoventilate. But as you can see, metabolic alkalosis, you hypoventilate. Now, what also made you hypoventilate? Respiratory acidosis. So, it can either be the cause or the compensatory mechanism for getting rid of it. And in this case, you'll be hypoventilating, but your pH will be in normal bounds. So that's why you can't just tell based off hypoventilation, hyperventilation, what kind of thing they're going through, because it could be either metabolic alkalosis, and their pH should be fine, or it could be the cause of respiratory acidosis, and their pH could be dropping. Alrighty, so that's that. Ciao.